Good morning, afternoon. We're still going to work on these notes, but we're going to skip ahead and we're actually going to the third method of solving. So you're going to skip all the way down to this one, verse 3. Substitution method is where we're going to start today. We'll finish up that middle section on Friday. So you would want to watch that music video again, but this time from 2 minutes and 39 seconds until the end. So you can hear this method. So our warm-up for today is making sure we can solve for y, and we've been practicing that quite a bit. So our first goal when we use substitution method is to isolate the variable. Which variable? Well, in our system, it doesn't matter, but here it says solve for y, so we're going to go for y. So to get y by itself, we just have to subtract 2x from both sides, which leaves us with y equals negative 2x plus 10 and 10, and we have it. Okay. Same thing here. We start the same exact way. We're going to add 5x to both sides. We're just moving that term to the other side of the equal sign. So we have 2y is equal to 5x plus 6. From here, since the 2 is being multiplied by y, we're going to divide both sides by 2. When we divide both sides by 2, we're going to divide every term by 2. It's like distributive property, but with division. Now you can write it separately. I like to write it together. On the right side, you'll see it separately later on. But 5 divided by 2, no need for a calculator. That's just our rise over run slope, 5/2. We go up 5 over 2. Sweet. Plus, okay, that one we can divide beautifully. 6 divided by 2 is 3. Ta-da! All right, final one with some funky fractions. We can get rid of the fractions. Since those are divide by 5s, if we multiply by the greatest common denominator, we get rid of those denominators. So if we multiply both sides by 5, we can get rid of those fractions. You're welcome to move them over and deal with the fractions, but hey, if we get rid of them, 5 times 2/5 x leaves us with 2x. 5 times 1/5 y gives us a positive 1y, and 5 times 2 is equals 10. From here, we only have one final step left. We subtract 2x from both sides, which seems very familiar from that first question. So we are left with y equals negative 2x plus 10. Beautiful. So this is a skill you're going to need to know, going to need to have for step 1. Occasionally, in your system of equations, you already have a variable alone. If that's true, you just move to the next step. But if we had this one, x has a 6, y has a negative 2, the other y has a 2, and the other x has a 3. We can't move on until we get x or y alone on them. Hence the lyrics right there. All right, so you could technically solve for any variable. You could solve for this y, you could solve for this x, you could solve for this x, or you could solve for this y. Choose the one that's easiest. And in this case, they're all about the same. So we're going to solve for y in equation 1. So they picked the first one, right? So this one up here, and we're going to solve for y. Why? Because they said so. So to get y by itself, as the boxes are here, we subtract 6x. Okay, cool. We've done that before. That way the 6x is gone. We are left with a negative 2y. I think we have an equal sign down there. Oh, yeah, we do. Okay, good. Equals, and then we have, I'm going to put the negative 6x first. That way we have it in slope-intercept form, plus 26 at the end. Our constant is over there. To get rid of that negative 2, we divide both sides by a negative 2. Now notice here's where they split it, so you can see each term is divided by negative 2. I like to just put it together, but the boxes are there, so we'll write it. Negative 2 divided by negative 2 is 1y. Done. Negative 6 divided by negative 2 is a positive 3. And 26 divided by negative 2 is a negative. Look, they already put it there. 13. Step 1 is complete. Now, this is kind of a fancy format. You don't always need to rewrite, but they told us to rewrite. So, okay, what's it? An expression is what you got on them. We got an expression, 3x minus 13. Lock it up, block it up. That's the way you chalk it up. So that is our key importance here. We are going to use the fact that y equals 3x minus 13 for our substitution. Okay. And then there's some part of me teaching up the pressures up. Check it, bro. Here we go. So plug this in with us like a cord in a socket. So we're going to substitute it in. Here we go. Where do we put it? Well, we put it where the y is in equation number 2. So in our second equation, 3x plus 2y, instead of y, we're going to put this entire expression in for y. So I'm going to put it right there. All right, so we have our 3x plus 2, and instead of y, we open up parentheses and put that 3x minus 13 in there. Hence our substitution method. We just substituted an entire expression into another equation. Woo! Parentheses will be helpful so you can see the distributive property. And from here, it helped us as well because we only have the variable x in there. We don't have an x and a y, so we can now solve for x. So we start with distributive property, distributing 2 times 3 and 2 times negative 13. So we have 2 times 3x is 6x. The front 3x just tagged along. And 2 times negative 13 is a negative 26. All right, cool. From here, you have some options, but what they decided to do here was combine like terms. So 6x plus 3x is 9x, and we still have that minus 26 there, but we got to get rid of the minus 26. So we add 26 to both sides. That way the 26's are gone. We are still left with 9x equals 36. Technically, from here, they divided both sides by 9, which gives us 4. Here, I'll put the divide by 9 if you really want to squeeze that in. We just found our x coordinate. So right there, we could go down to our final answer, and we know that our x value is 4. A lot of work, one number. Here we go. To get our final number, let's check in with our words here. Oh, look, we plugged it in like a cord in a socket. One variable is now all you have, right? We only had an x. Solve it up, do the math, did it. Find its value, 4. Take it back. We're going to take it back to the equations. Now, you could substitute that 4 in for x into either equation number 1, right here, equation number 2, right here, or the easiest is this locked it up, blocked it up, chalked it up expression. Because when you substitute that in, a lot of you can just mental math that. 4 times 3 and then minus 13. Yes. So we're going to write it out, though. So we're going to take that 4, and we're going to substitute it into our expression that we locked it up, blocked it up, chalked it up, this 3x minus 13. We're going to substitute 4 in for x. So we have 3 times 4. Now, I don't like to just put the 4 there. It looks like 34. Put the parentheses. Okay, there we go. From here, 3 times 4 is 12. 12 minus 13 is a negative 1, and we've found our y coordinate. So the solution to this system of equations is 4, negative 1. Now some of you are like, Miss Iceberg, can't we just graph this? Wouldn't that be so much easier? We need this method for when we try to graph and it's a fraction or it's a decimal. So that way we can be super precise and find the exact number. But for now, there's some nice whole numbers while we're practicing this method. All right, so we're going to do the next part, understanding the solution to the system, this system, right? There's our set notation. We have this equation and this equation in our system, is 2, 5. That is quite a claim. Show how you can verify that 2, 5 is indeed the solution to the system. All right, let's provide some evidence here. So if we want it to be a solution, the key is that we are looking for something that will make it true. If it is a solution, it is a true equation. So if we substitute it in, it's going to be a true statement. To the system, well, our system now is more than one. So it's all the equations, everything in there, all equations. And in this one for our system, Right now, we only have 2 equations. Systems can have 3, 4, 5, 6, 28. Kind of like our Desmos project. We had a lot of different equations in our system of equations. Lovely. All right, here we go. So we're going to substitute it into both of them. So I'm going to take the first equation, y equals 2x plus 1 over here. And I'm going to get it ready for substitution for color coding. Okay, cool. So my x is 2, so I'm going to put in 2 for x. My y is 5, so I'm going to put in 5 for y. And we're going to see if this is true. 2 times 2 is 4 plus 1. Again, I'm sure you can do this mental math. Beautiful. And 4 plus 1 is 5. Oh, that checks out. That is a true statement. That is a solution to that equation. In order for it to be a solution to the system, it needs to work for both. Here we go. Let's get our second one here. So we have our y equals negative 3x plus 11. So I'm going to set it up here for substitution so I can color code. My y is 5. My x is 2. And here we go. Let us solve here. So we have negative 3 times 2 is negative 6 plus 11. Oh, yeah, it is. 5 equals 5. A check. So it's true for all equations. Ta-da! So 2, 5 is the solution to the system of equations. All right, I'm going to do one more together with you. Right here, I'm going to do number 1, and then you're going to do number 2. Good news is the answers are right here, so you can try it and check. Okay, so I'm going to do number 1 with you. Okay, we can solve for this x, this y, or this y. I'm going to pick this y. Why? Because it's a negative 1, and when we divide, we only divide by a negative 1, which means we'll deal with no fractions. If we divide by 2 and solve for x, we'll have a 5/2, 9/7, 9/3. Oh, 9/3 wouldn't work too bad. Okay, so that's why I'm going to pick the y. So I'm going to solve for that first. So if you want to write that over here above the arrow, like solve for y, you can. So that's what I'm going to do here. So I'm going to first write it out. 2x minus y equals 5. And if we subtract 2x from both sides, we end up with a negative y. Be careful, that is a negative y minus 2x plus 5. And when we divide both sides by a negative 1, both sides, all of it, negative divided by negative is a positive, negative divided by a negative is a positive 2x, and a positive divided by a negative is a negative 5. Look, there it is. Block it up, chalk it up. That's the way you rock it up. I think I messed up those lyrics. So we just found that y is equal to 2x minus 5. So this 2x minus 5 is what we're going to substitute in to our second equation for y. So we take our first one, solve for a variable. Once we find that variable is isolated, we substitute that entire expression into the other equation for that variable, hence the name substitution. Okay, so here we go. We then have negative 3x plus 7. Instead of y, we are opening up a set of parentheses and substituting in that entire expression that we locked it up, chalked it up, blocked it up. That 2x minus 5. So we substitute that in. Now that we only have x's, we can just solve for x, which will start out with distributive properties. 7 times 2 is positive 14. 7 times 2x is a positive 14x. 7 times negative 5 is a negative 35. From here, we can combine like terms. 11x minus 35 equals 9. We can then add 35. Some of you were like ready to move and groove, and you're like, well, can't I combine like terms and get rid of the 35 at the same time? Well, yeah, they don't affect each other, so you could. We're going to have 11x is equal to, what is that, 44? When we divide both sides by 11, we get x equals 4. Oh, look, and it said our x coordinate is 4. All right, so we have found our x coordinate. Woo! To find the y, We could substitute that 4 into our first equation. We could substitute into our second equation, but it's much easier to just substitute it back into our expression over here on the right because our y is already isolated. When we substitute in that 4, right, we substitute in, oops, sorry, the color coding. We substitute in that 4 that we found, right? You can almost do that mental math without even writing it out. But I'm going to write it out because these are our notes. All right, here we go. So we have y equals 4 times 2 is 8 minus 5. Y is equal to 8 minus 5 is 3. Oh, look, we have x is equal to 4. Y is equal to 3. Look at our answer. So the solution to the system of equations is 4, 3. Our answer should be an ordered pair. We'll look at some word problems so you can know where this fits into real life in class. See you then.